I'm studying in Sri Venkateshwara College of Engineering. Today I'm discussed about the subject mathematics, in that properties of groups and subgroups. Introduction to groups. Groups are a fundamental algebraic structure in abstract algebra. A group is defined as a set of equipped with an operation that satisfies you for properties closure, associative, identity, and invertibility. Understanding groups is essential in various fields including mathematics, physics, and computer science. Closure property. The closure property states that the operation on any two elements in a group results in another element within the same group for a set is G, and an operation if A, B belongs to G, then A. Associative. Associativity means that the grouping of elements does not affect the result of the operations. For any element A, B, C in a group G, A your third bullet. Identity element. Every group contains an identity element that when combined with any element in the group yields that same element. If E is the identity in a group G, then for any element A in G, E, A equal to A. Inverse element. Each element in a group must have an inverse that, when combined with the original element, yields that identity element. For an element A in a group G, there exists an element B such that A, B equal to B. Subgroups. A subgroup is a subset of a group that is itself a group under the same operation. For a subset H of group G to be a subgroup, it must satisfy the properties of a closure, identity, and inverses. Subgroups are the important as they help in analyzing the structure of the larger group. Criteria for subgroups. The subgroups criteria state that if H is a non-empty subset of G, it is a subgroup if it is closed under the group operations and contain inverse. If AB belongs to H, then AB must also be in H for closure. Examples of subgroups. The trivial subgroup consists solely of the identity element and is a subgroup of every group. Any group is a subgroup of itself, which is known as the improper subgroup. Non-trivial examples include cyclic groups, which can be generated by a single element. Lagrange's of theorem. Lagrange's theorem states that the order number of elements of a subgroup divides the order of the group. If G is a finite group and H is a subgroup of G, then modulus of H divides modulus of G. This theorem highlights the relationship between groups and their subgroups and has implications in a group theory. Conclusion. Understanding the properties of groups and their subgroups is crucial in abstract algebra. These properties not only define the structure of groups but also provide tools for further mathematical operations. Groups and subgroups play a vital role in various applications, including symmetry, coding theory, and more. Feel free to modify any part of this presentation to better suit your needs. Thank you.